65 million years ago, something came hurtling from the far reaches of our solar system and nearly wiped out all life on Earth. It wasn't an asteroid from the asteroid belt, it was a comet. A big frozen rock that came from a mysterious, unseen sphere of ice, rock, and primordial debris that surrounds our entire solar system, the Oort Cloud. And the unsettling part is that the Oort Cloud could possibly be filled with millions of similar frozen time bombs. One big enough could be nudged or pulled by a planet or passing star and sent on a deadly trajectory toward Earth, turning our planet into nothing more than a lifeless rock drifting through space. And now, something even bigger has been discovered emerging from this ancient graveyard of ice and rock. A mega comet, so massive it dwarfs the one that ended the age of the dinosaurs. But the Oort Cloud isn't just a distant threat, it's a mysterious structure at the very edge of our solar system, hiding secrets that could reveal new dangers and even life. The inner edge of the Oort Cloud begins somewhere around 2,000 times farther from the Sun than Earth is, more than 50 times farther away than Pluto. It's never been directly observed by any telescope, and no spacecraft has ever reached it, including the Voyagers. In fact, it will take another 300 years for Voyager 1 to make it to the inner edge, and another 1,000 years to traverse it. The Oort Cloud is believed to be a graveyard of ancient material. Billions of years ago, when the solar system was young, the giant planets were moving through a violent phase. Their gravity flung debris outward in all directions. Some of that material escaped completely. Some fell back toward the inner solar system, but most of it drifted far beyond the planets. It settled at the very edge where the sun's gravity becomes so weak that even the pull of nearby stars can begin to compete with objects in the icy Oort Cloud. Over time, this scattered debris formed a sphere, not a perfect or uniform sphere, but a massive shell made of trillions of icy objects frozen solid in the cold, icy darkness of space. Some of them are the size of mountains, while others are no larger than a boulder, out there, drifting, waiting for something to tug on them and pull them from their icy domain. The total number of objects in the Oort Cloud is unknown, but some estimates suggest there could be as many as 1 trillion. That's more than all the stars in the Milky Way galaxy. Once in a while, comets that take 200 years or longer to orbit the Sun, called long-period comets, suddenly show up in telescopes. They aren't like the regular comets that circle the Sun every few years. These ones have orbits that take thousands or even millions of years to complete. Comets from the Oort Cloud could come towards us from anywhere at any time. And from time to time, something disturbs something in the Oort Cloud. It could be a passing star, a gravitational ripple. Once in a while, something nudges one of these objects from the cloud, and it begins a long gravitational fall toward the Sun. Sometimes comets show up quietly with no warning. Other times they become a blazing ball of dirty ice and rock with a glowing tail that can be seen with a telescope. Some comets survive, others break apart. Most of them disintegrate when they get too close to the Sun, and a few have collided with planets, including our own Earth. So this frozen shell around us isn't just a distant curiosity, it's also a source of potential danger, and now something huge has been pulled from its icy grave. In 2010, the largest comet nucleus ever discovered was made. Bernardinelli-Bernstein is a mega comet that was spotted while it was more than halfway to Neptune, at an astonishing distance of 16.6 times the distance between the Sun and Earth. And it's a massive behemoth, measuring nearly 85 miles across. That's more than 10 times the size of most known comets. To further put this into perspective, the Chicxulub comet was estimated to be somewhere between 6 to 9 miles in diameter. Tiny compared to this monster. In fact, it's big enough to be called a minor planet. But not only is this thing massively huge for a comet, something else surprising about it was just recently discovered. While studying this huge ball of rock and ice, molecular activity was detected. Using the very powerful Atacama Large Millimeter Submillimeter Array telescope in Chile, explosive jets of carbon monoxide gas were seen erupting from the comet. Outgassing patterns of light and thermal emission were recorded. This is a big deal, because it's the very first time that molecular outgassing of a comet has ever been seen. But why is this discovery so groundbreaking? Most comets don't become active until they're much closer to the Sun, typically inside Jupiter's orbit. Since Bernardinelli-Bernstein comes from the Oort Cloud, objects there have been essentially unchanged since the solar system's formation 4.6 billion years ago. This molecular activity will tell us more about the composition and behavior of primordial materials, the building blocks of the materials that created all the planets in the solar system. Because of this, we know that Bernardinelli-Bernstein has preserved materials from our outer solar system's formation, and the CO activity gives us direct chemical analysis of that primordial material. But that's not all. The detection of carbon monoxide jets at such extreme distances far from the Sun challenges our understanding of what drives comet activity. Traditional models suggest water ice sublimation powers most comet activity, but this occurs much closer to the Sun. The CO activity suggests different volatiles can drive outgassing at much greater distances. Basically, there's some activity going on inside this comet, and it's got nothing to do with the Sun. We may be looking at mega comets that behave differently from regular comets, powered by unknown exotic ices that can drive activity in the deep freeze of the outer solar system. This discovery opened a window into both the most ancient materials in our solar system and the extreme physics of comet activity at the frontier of interplanetary space. It's like finding a time capsule that's suddenly come into life after billions of years of dormancy. Now, some of you may be asking, does this thing have a chance to hit us? This seems to be the normal question when a massive object like this is discovered. We know the most famous impact event was likely caused by a comet or asteroid, but there's strong evidence that some ancient extinctions were triggered by comets. Comets move faster than asteroids. Their impact force can be even greater, and the worst part, you don't see them coming. An asteroid in the inner solar system can be tracked. We know where many of them are and how close they'll come. But a long-period comet from the Oort Cloud can appear suddenly. It could be the size of a city and travel at tens of thousands of miles per hour. And because it comes from so far away, we might only get a few months of warning, maybe even less. Jupiter has stopped a lot of asteroids and comets from hitting Earth, but it's very likely that the gravity of Jupiter is what pulled on the Chicxulub impactor and flung it our way. Could it happen again? It's possible. But there's no need to worry about Bernardinelli-Bernstein. It's not coming anywhere near Earth. But what about those gas jets? Can they change the trajectory of the massive dirty snowball? This is actually a fascinating idea. The CO jets we're seeing can create what's called non-gravitational forces that slightly alter a comet's path, like tiny rocket engines. However, given this comet's enormous mass, which is millions of times heavier than typical comets, the outgassing effects would be minimal compared to gravitational forces from the Sun and planets. The orbit is extremely well established since we've tracked it for over a decade, so there's no chance these gas jets could redirect it toward Earth. If anything, they would make microscopic adjustments to its already safe trajectory. The comet will make its closest approach in 2031, reaching Saturn's orbit. As it continues its journey inward, we'll get unprecedented observations of how a megacomet evolves and becomes more active. It will not be visible to the naked eye because it will not enter the inner solar system. It will reach its closest point to the Sun at 1 billion miles in January 2031. But this is a big reason why the Oort Cloud matters. It's not just an invisible structure or rock, ice or other debris. It's the source of some of the fastest and most unpredictable objects in the solar system, and it sent them our way before. Something disturbed objects like Bernardinelli-Bernstein. Something pushed them out of orbit. But we don't know what it was. It could have been a passing star. It could have been something else. Something massive, and something we haven't found or seen yet. We like to think we understand the solar system. We've mapped the planets. We've landed on the moon. We've sent spacecraft and rovers to Mars, to Saturn, even beyond Pluto. But all of that, everything we've ever touched, exists inside a tiny bubble. The Oort Cloud is where that bubble ends. It's the last breath of the sun's reach. Beyond it, there's no map, no warmth, no light. Just open space, cold, silent, and endless. But that isn't all that makes up the solar system, and it's not the only bubble around us. In fact, there's something even more strange that was discovered surrounding our solar system. On November the 14th, 2023, Voyager 1 suddenly fell silent, sending back only a meaningless stream of binary data. It seemed the spacecraft, which had ventured beyond the solar system, was lost forever. The cause turned out to be memory failure in its onboard flight data system, FDS, risking permanent loss of communication. However, the team of scientists refused to give up. They made the bold decision to reallocate code to other areas of the probe's memory. This process began on April the 18th, 2024, and came with a great risk. The signal took 22.5 hours to reach Voyager, and it takes the same amount of time for a response. Every attempt was a step into the unknown. Just 2 days later, after months of intense work and anticipation, something incredible happened. Voyager 1 re-established contact. What extraordinary discoveries did the Voyagers make at the boundary of the solar system? Why did it turn out to be so different from what scientists had imagined? And what was contained in the mysterious signal that Voyager 1 sent after months of eerie silence? In the late 1970s, a rare event occurred in the solar system, a planetary alignment that happens only once every 175 years. In that moment, the gas giants lined up on one side of the solar system, creating a unique opportunity to study them in a single mission. NASA seized this chance. Voyager 1, launched after its twin overtook Voyager 2 thanks to a faster trajectory, reaching speeds of 38,000 miles per hour compared to Voyager 2's 34,360 miles per hour. Just 13 days after launch, it captured an historic photo of Earth and the Moon from a distance of 7.2 million miles, which became the symbol of the start of their grand journey. In 1979, both probes reached Jupiter, revealing its previously unknown rings, discovering 3 new moons, and capturing detailed images of its largest satellites. They confirmed that Ganymede is the largest moon in the solar system, as opposed to Titan, that was previously considered largest. They also discovered that Europa's surface is covered in smooth ice riddled with cracks. It's this data that gave origins to the hypothesis of a subsurface ocean, something we covered in another of our videos. Additionally, the scientists had their first close-up view of Jupiter's Great Red Spot, a centuries-old storm larger than Earth. Jupiter was just the first stage of their grandiose journey. Using its gravity for a speed boost, both probes reached Saturn in 1980 and 1981. This marked a turning point in the Voyager mission. Initially, the mission was planned to last only 4 years to study Jupiter and Saturn, but NASA designed the mission's trajectories to allow for potential exploration of other planets. A key decision was the close approach to Titan, the only moon in the solar system with a dense atmosphere. Ultimately, Voyager 1 was directed toward Titan, sacrificing its ability to continue the journey, while Voyager 2 was sent onwards to Uranus and Neptune. The probes delivered detailed images of Saturn and its rings, revealing that they consist of hundreds of narrow, intricately structured rings. 4 new moons were also discovered. Mimas was of particular interest, notable for being dotted with many craters, including, most notably, the massive Herschel crater, giving the moon a striking resemblance to the Death Star from Star Wars. Titan, however, harbored an unpleasant surprise. Its atmosphere was opaque to visible light, preventing us from uncovering the mysteries of its surface. However, analysis showed that Titan's temperature was close to the triple point, a unique condition where methane behaves similarly to how water does on Earth. After Saturn, the paths of the two probes diverged forever. Saturn's gravity significantly accelerated Voyager 1, altering its trajectory and making it the fastest spacecraft in history. Voyager 2, meanwhile, continued its planetary tour, heading for Uranus next. It reached Uranus in January 1986, coming within 50,600 miles of its surface. Scientists were surprised to find that Uranus was vastly different from Jupiter and Saturn. While the gas giants are composed of 90% hydrogen and helium, Uranus contains these elements only in its atmosphere. Beneath lies an ocean of water, ammonia, methane, and hydrogen sulfide, with a core of rock and ice at the planet's center. Later, planets of this type were given the name of an ice giant. Uranus also turned out to be the coldest planet in the solar system, even colder than Neptune. After collecting data on its Uranus mission, Voyager 2 moved on to its final target, Neptune. It reached Neptune in August 1989 and remains the only spacecraft to have visited the 8th and most distant planet in the solar system. On August 25, 1989, Voyager 2 captured the first detailed images of Neptune, completing its grand tour. The planet appeared vividly blue, though later data revealed its true color is closer to teal. While Voyager 2 explored Uranus and Neptune, Voyager 1 could only envy the other spacecraft. After its Saturn mission, the engineers disabled a significant portion of its instruments, only leaving technology for studying the environment data. However, after Voyager 1 had another chance to make history. On February 14, 1990, from a distance of 3.72 billion miles, it captured Earth as a tiny, pale blue dot, just 0.12 pixels in size. This iconic photo, known as the pale blue dot, became the last image ever taken by Voyager 1 before the cameras on both probes were permanently shut down. Next, our cosmic travelers entered a long period of calm, lasting a decade and a half, which was interrupted by an extraordinary event. On August 25, 2012, Voyager 1's instruments recorded a sharp drop in charged particles emanating from the Sun, along with a rise in galactic cosmic rays. This meant that the spacecraft had finally entered interstellar space, leaving the region where the Sun's influence ends and interstellar radiation dominates. The slower-moving Voyager 2 crossed the same boundary in November 2018. The unique bubble of our solar system, called the heliosphere, extends about 11 billion miles from the Sun. It's formed by the solar wind, a stream of particles from the Sun, and ends at the heliopause, which is the boundary between the heliosphere and the interstellar medium. The Voyagers are the only spacecraft to have crossed this boundary and exited the solar system. What they discovered out there sparked widespread interest and active discourse among scientists. Previously, it was believed that the solar wind gradually weakens as you get further from the Sun. However, data from the probes showed that the solar wind doesn't fade, but instead reaches a sharp boundary. Beyond this boundary, its influence ceases, and interstellar space begins. This means the solar wind doesn't simply dissipate, but changes direction, forming a physical boundary between the two environments. The solar wind flows around the heliopause from the inside, while interstellar plasma flows around it from the outside. We were also able to determine the shape of the heliopause. On one side, it resembles a sphere, while on the other, it stretches into a long tail. Curiously, this shape is not static. The boundary of the solar system is constantly moving. The surface of the heliosphere is distorted by massive waves that appear at unexpected, non-uniform angles. These waves can reach 10 astronomical units, equivalent to 10 times the distance between the Earth and the Sun, or about 930 million miles. Additionally, by studying Voyager data, scientists discovered that the heliopause underwent rapid changes over a very short period. This may explain why the time difference for the two probes crossing the heliosphere's boundary was so large, 6 whole years. However, these changes in the movement of the heliopause contradict existing scientific models and remain unexplained. Similarly, the temperature and density of the solar wind near the heliopause defy explanation. Astrophysicists had expected that the slowing of solar particles by interstellar radiation would cause a sharp increase in temperature and density. While this did happen, the measured values were 10 times lower than the theoretical predictions. Where this energy is lost remains unclear. Data from Voyager 1 and Voyager 2 spacecraft also revealed that interstellar space consists of denser, colder plasma, while the plasma near the solar system's boundary is hotter and less dense. Importantly, these two types of plasma interact with each other. Particles from the solar wind and interstellar wind mix, creating a sort of boundary layer between the heliopause and interstellar space. But the interaction between the Sun and interstellar space doesn't end there. Shock waves emitted by the Sun can pass through the heliopause into interstellar space, creating disturbances similar to those caused by supernovae, which generate shock waves spreading through interstellar space. Thanks to the Voyagers, scientists also learned that the interstellar magnetic field is 2 to 3 times more powerful than previously thought. This, in turn, means that interstellar particles exert 10 times more pressure on the heliosphere than expected. The data obtained from this interaction provides a more comprehensive understanding of what occurs between the Sun and interstellar space. These insights can be applied to all stars that are being studied by astronomers, as it's believed that other stellar systems likely share the same properties and processes as our solar system. Throughout their journey through interstellar space, the Voyagers have continued sending signals to Earth, transmitting data about the status of their instruments and their locations. However, in 2022, Voyager 1 unexpectedly transmitted a strange signal. While 14.6 billion miles away from Earth, it began transmitting chaotic data about its position, sequences of zeros or the number 377. This mysterious signal puzzled scientists. The numerical sequence could have either contained critical information or indicated a malfunction. Later, it was discovered to be the latter. The issue was related to the spacecraft's altitude control and maneuvering system. Although it was still possible to control the spacecraft manually, Voyager 1 lost precise awareness of its position, likely due to cosmic radiation affecting its navigation system. NASA engineers successfully resolved the issue by transmitting telemetry through another onboard computer. Another alarming event occurred when Voyager 1 went silent for an extended period starting on November 14, 2023, lasting 5 months. This was caused by corrupted code on one of its chips. To fix the problem, the team made a decision to reallocate the code to other sections of the onboard computer's memory. On April 18, 2024, the process of transferring the data began, which required significant time. After sending the signal, the team had to wait 22.5 hours for it to reach the spacecraft and another 22.5 hours for a response. By April 20th, the team confirmed the success of the operation, and after 5 months, scientists were able to restore communication with Voyager 1 and verify its functionality. These malfunctions remind us that the lives of our cosmic travelers are nearing their end. NASA hopes the Voyager's instruments will function until 2025, after which a phased shutdown will begin. In a few years, the spacecraft will lose the energy needed to communicate with Earth, likely around the 50th anniversary of the mission. This will mark the final chapter of this project. Even after losing contact, these cosmic travelers' journeys will continue. They may witness many fascinating phenomena, though they'll no longer be able to tell us about it. Voyager 1 is moving away from us at a speed of about 3.5 astronomical units per year. 1 astronomical unit is the average distance between the Sun and Earth, approximately 93 million miles or 150 million kilometers. Voyager 1 is currently heading toward the constellation Ophiuchus. In the year 4272, 38,200 years from now, it will approach within 1.7 light-years of a little-known star in the constellation Ursa Minor called AC +79388. Its twin, Voyager 2, is leaving the solar system at a speed of about 3.1 astronomical units per year. Around 40,000 years from now, it will approach within about 1.7 light-years of a star named Ross 248, a small star in the constellation Andromeda. Currently, Voyager 1 is approximately 15.5 billion miles away from Earth, while Voyager 2 is 12.4 billion miles away. Although they passed the Sun's heliopause long ago, it's not entirely accurate to say the Voyagers have fully exited the solar system. Scientists believe the solar system encompasses everything within the Sun's gravitational influence. Today, it's hypothesized that the final frontier of this influence is the Oort Cloud, a hypothetical spherical region surrounding the solar system, which serves as the source of comets that periodically enter our planetary system. The Oort Cloud includes two distinct regions, the spherical outer Oort Cloud and an inner disc-shaped region. The estimated distance to the outer edge of the Oort Cloud from the Sun ranges from 50,000 to 100,000 astronomical units, equivalent to the distance light travels in a year. Voyager 1 will take approximately 300 years to reach the inner edge of the Oort Cloud and possibly around 30,000 years to traverse it, marking its ultimate departure from the solar system. If, on their distant journeys, the spacecraft encounter extraterrestrial life, they're equipped with messages prepared by a team of scientists. These include a phonographic record on a gold-plated copper disc. About 3/4 of the recordings are music. The disc also contains greetings in various languages, messages from the US President and UN Secretary General, sounds of Earth, human voices, whale songs, brainwave recordings, and more. It would be plenty for the aliens to occupy themselves. But if the Voyagers are never discovered, they'll continue drifting peacefully through the dark, cold interstellar void. They'll remain a symbol of humanity's quest for knowledge and a reminder to the universe of the ambitions and hopes of the inhabitants of a small, pale blue dot. In 1977, Voyager 1 and Voyager 2 launched from Cape Canaveral less than a month apart. By the way, Voyager 2 launched earlier, but since it had a different flight path, it flew to the edge of our solar system second, 6 years after its colleague. Both devices found a very strange anomaly. As you move away from the Sun, the density of space increases. Interstellar space is usually considered a vacuum, but this is not entirely true. The density of matter is extremely low, but it still exists. In the solar system, the solar wind has an average density of protons and electrons of 3 to 10 particles per cubic centimeter, but it's lower the farther from the Sun. The smallest density of space is at the edge of the solar system. This boundary is called the heliopause. On it, the speed of the solar wind, the flow of charged particles emitted by the Sun, or in other words, solar plasma, drops to zero. The area between the Sun and the heliopause is called the heliosphere. This is a kind of bubble in which all the planets of the solar system are immersed. At this boundary, the density of protons and electrons is 0.002 particles per cubic centimeter. According to calculations, the density of particles behind the heliopause, that is, in interstellar space, should be 0.037 particles per cubic centimeter. The Voyager 2 instrument showed that the density outside the solar system, at a distance of 119.7 astronomical units or 17.9 billion kilometers from the Sun, was 0.039 particles per cubic centimeter. This almost coincided with the calculations, but then the strangeness began. At a distance of 124.2 astronomical units or 18.5 billion kilometers, the density was 0.12 particles per cubic centimeter. Why is the density increasing? We'll definitely talk about this a little later, but for now, let's talk about another bubble, much larger than the heliosphere, so that you'll appreciate all the thoughtfulness of the cosmos that packed us into two bubbles at once and understand the relationship between them. When you look at the pictures of deep space, you get the impression that it's filled with clouds of interstellar dust and luminous gas. But back in the 70s and 80s of the last century, astronomers began to pay attention to the fact that the galactic space around the Sun differs from this picture. The solar system seemed to hang in an almost absolute void. This year, scientists at the Harvard-Smithsonian Center for Astrophysics, CFA, proved that yes, we really are in a kind of void. They conducted the most complex computer simulations, creating a three-dimensional reconstruction of space and time. The study showed that the Sun and Earth are located almost in the center of a giant bubble with a diameter of 1,000 light-years, which they called the local bubble. According to calculations, it began to form about 14 million years ago. For this, it's necessary that about 15 supernovae explode over several million years. This series of explosions pushed the interstellar gas outward with the pressure of light, creating a bubble-like structure with a dense surface at the boundary. And now, the bubble continues to grow in size. When the bubble first formed, it was expanding at about 60 miles per second, according to data collected by the European Space Agency's Gaia Space Observatory. At present, the bubble is still expanding at 4 miles per second. On its surface, 7 star formation regions were detected, dense molecular clouds where stars are formed. The process of star formation occurs everywhere on the surface of the local bubble, and there are many such bubbles in the galaxy. Therefore, it's possible that there are other stars, even with planets which, like us, are also in their local bubbles. Interestingly, the Sun was not at the center of our universe at first. When these catastrophic explosions occurred, the Sun was far away from the scene, about 1,000 light-years away. But, as João Alves, an astrophysicist at the University of Vienna, explained, about 5 million years ago, as it orbited the center of the galaxy, the Sun got almost right at the center of the bubble. This is consistent with estimates of radioactive iron isotope deposits from a supernova in the Earth's crust from other studies. The researchers suggest that there are probably more star formation bubbles in the Milky Way. Research author and astronomer of CFA, Elisa Goodman, who founded GLUE, explains in her statement that, statistically, the Sun would not be near the middle of a huge bubble if they weren't spread all over the place. The local bubble is exactly the bubble we're in right now, she said. We think the Sun has probably gone through a lot of superbubbles in its history. The scientists compared the cosmos with Swiss cheese. The holes in the cosmos are punched out by supernova explosions, and new stars are being formed on the edge of the holes created by dying stars. The research team plans to map more cosmic bubbles to get a full 3D representation of their shape, location, and size. By charting out where the bubbles lie across the vast expanse of space, astronomers can piece together how these bubbles act as nurseries for stars, how the bubbles interact with each other, and how galaxies like the Milky Way have evolved over time. With the opening of the local bubble, the structure of the solar system looks like this. At its center is the Sun, around which 8 planets revolve. The last one is Neptune, at a distance of about 4.45 billion kilometers or 30 astronomical units. That is 30 times farther from the Sun than the Earth. Behind Neptune is the Kuiper Belt, a collection of small celestial bodies, the most famous of which is Pluto, which has long been considered a planet. The Kuiper Belt stretches out to about 55 astronomical units. Further, at a distance of 125 to 135 astronomical units, there is a heliopause, which we've already described. Let us now explain why the density begins to increase at its boundary. It's because solar plasma collides with interstellar plasma here. Imagine 2 streams colliding head-on at cosmic speeds. Of course, at the point of collision, the density increases. It's like a traffic jam, a chaos of particles. And behind this jam, at a distance of 0.75 to 1.5 light-years, the Oort Cloud spreads, a spherical cloud of ice objects up to 1 trillion, which serves as a source of long-period comets. The interstellar wind already dominates here, but the Sun is still holding bodies in its gravitational field with its last strength. Of course, many of our viewers may ask the question, well, we're in a bubble that's huge by earthly standards, even in a double bubble, local and heliosphere. Well, so what? How does this affect our lives? About that small bubble, the heliosphere, we can say unambiguously that thanks to it, thanks to the traffic jam that formed on its border, the Earth is reliably protected from high-energy cosmic particles rushing from the center of the galaxy. Now for the local bubble. Scientists have long found out that our galaxy, the Milky Way, has the shape of a spiral disk. Several spirals diverge from its center, which astronomers call arms. Right now, our Sun is almost halfway between the Sagittarius arm and the Perseus arm. And our Sun revolves around the center of the galaxy. It makes one revolution in 200 million years. We call this a galactic year. Only 0.0008 of this year has passed since the appearance of man. In its path, the Sun, with all its planets, crossed not only bubbles, but also accumulations of interstellar gas, when the density of matter in space jumped hundreds of times. Astrophysicist Miroslav Filipovich, using the latest model of the Milky Way, checked what happened on Earth when the Sun crossed the galactic arms in which the density of interstellar space is much higher. A relationship has been found between the time the Sun crossed the spiral arms and 5 known mass extinction events: 415, 322, 300, 145, and 33 million years ago. So we can assume that now the Sun is in a quiet harbor, favorable for all living things. And we can say that humanity is very lucky that we appeared on Earth as a species when the Sun flew into the local bubble before that. Or maybe these two events are somehow connected: the appearance of man and the presence of the Sun in a safe haven, the local bubble. Science has no information about it, at least not yet. But we can definitely say that we observe such a colorful sky above our heads only due to the fact that we're practically in a void, the local bubble. If the space around us was denser, many stars would be invisible, and who knows if we would know about space and about the structure of the universe as much as now if we were literally in the dark. And we can say that the local bubble is just a gift to humanity, which has entered the space age and is already trying to jump to the stars. For an interstellar craft moving at subliminal speeds, the greatest threat is dust particles, which will simply grind the ship to powder during collisions. Even hypothetical concepts such as ships imply a frontal shield. But now, it turns out that the cosmos seems to have taken care of us. It removed the dust in the vicinity of the Sun and, as it were, says, "Forward, guys, the path to Alpha Centauri and Tau Ceti is open." Stay tuned for updates to keep up with the greatest achievements of mankind. Thank you for watching. It looks like space is an abandoned, empty place without the slightest sign of another civilization like us. But does this mean the universe is absolutely silent and nobody except us has tried to explore it? Scientists' recent discoveries may prove otherwise. The farthest space probe, Voyager 1, has been traveling for almost 44 years now and still sends back data to Earth. And one day, scientists heard a shockingly strange cosmic hum. Even though the probe has already sent similar recordings in the past, the newly discovered signal was significantly different. For the first time in human history, we got the chance to explore what's hiding outside our solar system. The signal was found more than 14 billion miles from Earth. It was a sound that remained steady at 3 kHz for almost 3 years in a row. This has become the most stable and long-lasting hum ever detected by Voyager 1, and scientists were only able to discover it once the spacecraft got far enough. But where did this mystical sound come from? Most scientists believe the hum is a result of the plasma waves traveling somewhere in the depths of the universe. Now, plasma is a sort of major building material that nearly all cosmic objects consist of and emit. What's truly mind-blowing is that this sound stayed nearly the same, even after the probe flew for another billion miles. Such a level of consistency prompted other scientists to think there may be some source of energy causing this hum that we don't know about yet. But how is that possible if there's no sound in space? Well, it's true that sound fades away too fast in the vacuum of space since there aren't enough particles there for it to travel through. Even such sounds as black hole collisions or massive explosions of supernovas don't stand a chance. Here's a quick experiment. Put a tiny bell into a plastic bottle and screw the cap on. Now shake the bottle and listen to the bell. Now take off the lid, put 2 burning matches inside, and quickly put the lid back on so they burn out. Once the air in the bottle cools, shake it again. Notice how the sound is quieter, or is not there at all. Nevertheless, there are different electromagnetic waves that travel through a vacuum without problems, and radio waves are one of them. Although our human ears cannot spot such signals, scientists found a way to convert them into sounds, and now we can hear the message Voyager 1 sent us. So, how did Voyager 1 manage to gather such faint signals and send this data to Earth? Well, the spacecraft was designed with two hypersensitive antennas designed to detect plasma variations in space and record them. But even using radio signals for communication that travel at the speed of light, more than 20 hours have to pass to cover such a distance. The sad truth is that soon we won't receive any signal from Voyager 1. According to scientists, it's currently running out of power, so the probe's crucial instrument may function for 3 or 4 more years. Voyager has already done more than we've ever expected, and it could still surprise us with more life-changing discoveries throughout the following years. Even though the latest probe's finding is kind of a big deal, NASA has previously discovered some other weird sounds that puzzled scientists. In 2007, researchers unexpectedly came across something bizarre stored in a few years old data. What they revealed were so-called FRBs, fast radio bursts. These are so quick that each burst only lasts about a millisecond. From this point, researchers have started searching for other possible FRBs, and they found tons of them. This is how these radio bursts sound. So far, it seems the more we find out about the universe, the more questions there arise. Could it be an attempt of an intelligent alien civilization reaching out to us? Or maybe this wasn't intended for our eyes and ears? Who knows? The majority of astrophysicists think these FRBs either come from black holes or massive neutron stars, probably the smallest yet some of the heaviest and densest stars out there. Other professors had a more thrilling idea of what was actually happening. Their theory is that these were powerful, misaimed alien radio signals that were intended to charge their light-driven cosmic ships at huge distances. What both sides do agree on is that these FRBs must come from an unimaginably distant source somewhere billions and billions of light years away from our galaxy. And while our technologies are limited to look that far, we seem to have harnessed our own solar system quite well compared to interstellar space. And NASA occasionally notices spooky sounds way closer within our planetary system. Let's take a look at Jupiter's moon, Ganymede. Here's the disturbing sound it makes. The reality is that these sounds are as a result of chorus waves, coherent electromagnetic waves. Now, these waves frequently cause auroras or polar light, and the Earth is not the only place you can see those. This breathtaking phenomenon happens on Saturn, Jupiter, and Ganymede as well. So, what you've just listened to could be basically a converted sound of polar lights on Ganymede. What about Mars, though? We've been studying it for quite a bit already, and NASA's Perseverance rover has just come across something fascinating. The first actual sound of the rover driving over Mars has been recorded. But what's interesting about it? Well, along with the noise of the metal wheels rolling on a rocky planet surface, Perseverance has captured an unidentified, high-pitched scratching sound. Here's the actual recording sent by Perseverance. Nobody knows what the cause of this scratching noise is, and while NASA's scientists try to get a clue, the mystery remains unsolved and leaves room for imagination. Scientific and technological progress do not stand still. In 2030, a prospective interstellar probe mission may take place. Scientists say this could be just as revolutionary as the very first attempt to land on the moon. Just imagine the largest rocket flying the highest possible speed to get 10 times farther than Voyager 1 got at the bare minimum. An expected lifespan for such a spacecraft is 50+ years, but given Voyager's success and today's advanced technologies, everybody hopes to see this number rise. This would be humanity's first significant step into the realm of stars. The mission's primary objective is to capture our entire solar system from a huge distance and continue with the exploration of interstellar space. Once done, we will finally get closer to defining our place in the universe and unraveling the mystery of deep space. In the history of spaceflight, only 5 spacecraft launched by humanity have the momentum to leave our solar system. The Voyagers are 2 of these spacecraft, and they've ended up discovering more than we thought they would, and have lasted a lot longer than NASA predicted. We think they're just not given the love they deserve, so we're now going to tell you some really interesting things about them you might not know, what they've discovered, and where they're headed. Officially approved back in 1972, the Voyager project was originally called Mariner Jupiter-Saturn, and the probes were previously named Mariner 11 and Mariner 12. But NASA decided to change the name because these 2 new probes had progressed sufficiently beyond that of the Mariner spacecraft family. In other words, they were much more advanced. Now, while we're on the subject, it's really interesting to look at the technology and hardware of these vintage probes. These spacecraft were launched an astounding 44 years ago. Voyager 2 on August the 20th, 1977, and Voyager 1 2 weeks later on September the 5th, 1977. This was at a time when important advances were made in the science of gravity-assisted orbital trajectories, or in other words, the ability for spacecraft to use the gravity of a nearby planet to give it a large boost in velocity, as long as the spacecraft follows the intended or mapped out orbit. First, let's talk about the computers, which are identical in both spacecraft. Each computer system aboard the Voyager spacecraft is a dual redundant, meaning there was 2 of everything in the event one computer system should fail. The computers aboard the Voyager probes each have just 69.63 kilobytes of memory total. That's only enough space to store an average-sized JPEG photo file. Each of the space probe's scientific data is encoded on old-fashioned digital 8-track tape machines. However, they aren't anything like your grandfather's 8-track stereo in his classic muscle car. There aren't any physical examples that exist, or anything sitting in a museum somewhere. But we do have a photo of it. Yes, this is the data tape recorder that was subcontracted to Lockheed and manufactured by Odetics Corp for both Voyager spacecraft. It could record data at 2 different speeds, 115.2 kilobytes per second and 7.2 kilobytes per second. Playback topped out at a much slower 57.6 kilobytes per second, with 33.6, 21.6 and 7.2 kilobytes per second being options as well. Exactly what the magnetic tape was made of and what secrets were used to keep it from degrading in the harsh environment of space is unclear. Whatever those secrets are, they seem to have worked because the DTRs in both spacecraft performed flawlessly from their launch through the entire Grand Tour mission and even the extended mission that set both of these spacecraft on a course out of our solar system. The Voyager spacecraft computers are capable of executing about 81,000 instructions per second. Your smartphone that you might be watching this video on is probably around 7,500 times faster than that. They transmit data back to Earth at 160 bits per second. To give you an idea of that speed, if you used this same connection, it would take you around 8.5 years to download a 5 gigabyte movie from Netflix. But probably the most interesting thing aboard each spacecraft, the Voyagers have something no other spacecraft have: a golden phonograph record. These 2 gold-plated copper discs contain 115 analog encoded photographs, greetings in 55 languages, and a 12-minute montage of sounds on Earth, and 90 minutes of music. These were made in the event an extraterrestrial civilization ever finds one of these probes. Powering each spacecraft are 3 plutonium dioxide radioisotope thermoelectric generators, or RTGs, mounted at the end of a boom. Each probe was fitted with 11 different scientific instruments, which, if we explained in detail, would take easily over an hour. Instead, let's look at a few of the exciting things the Voyager probes found, and the images captured during their missions using these instruments. Both spacecraft have been traveling along different trajectories and at different speeds. Voyager 1 is traveling faster at a speed of about 61,155.07 kilometers per hour, compared to Voyager 2's velocity of 56,327.04 kilometers per hour. Voyager 1 captured incredible images of Venus, Jupiter, Neptune, Saturn, and Uranus. Voyager 1 also captured an incredible image of Jupiter's moon, Io, where a volcano was seen erupting from the surface. It was the first time ever that an active volcano had been seen elsewhere in the solar system. But the most famous image Voyager 1 captured was of the Earth, or what is famously known as the pale blue dot, taken February 14, 1990, at a distance of 6 billion kilometers away, and inspired the title of Carl Sagan's book, A Pale Blue Dot, A Vision of the Human Future in Space. Voyager 2, on the other hand, began transmitting images of Jupiter on April 24, 1979, that were put together to show a time-lapse movie of the gas giant's atmospheric circulation, including the infamous Great Red Spot Storm that's 3 times the diameter of Earth. Voyager 2 was able to do this because it made closer passes to Jupiter and the Jovian moons. On August 25, 1989, Voyager 2 flew by Triton, one of Neptune's moons. The Voyager 2 data was used to construct this video of its exciting encounter and showed us Jupiter as we'd never seen it before. Between them, Voyager 1 and 2 explored all of the giant planets of our solar system and 48 moons, a unique system of rings, and the magnetic fields of each of the outer planets. But this wouldn't be all Voyager 1 and 2 would discover, as you're about to find out. In fact, they would encounter something far more mysterious and unknown, and something they weren't even designed for. Voyager 1 entered interstellar space on August 25, 2012, and was the first human-made object to do so. As Voyager 1 left the heliosphere, which is a giant bubble of charged particles that the Sun blows around itself, the probe recorded a 1,000-fold drop in heliosphere particles and a 9% increase in galactic cosmic rays that come from outside the solar system. Since flying into interstellar space, Voyager 1 has sent back some information about the conditions in this dark zone of the universe. One of those discoveries is that the cosmic radiation out there is very intense and demonstrates how charged particles from the Sun interact with particles emitted by other stars, and how this bubble of charged particles protects everything inside our solar system from those deadly cosmic rays. On November 5, 2018, Voyager 2 became the second spacecraft ever to enter interstellar space when the probe registered a sudden decrease in solar wind particles emanating from the Sun, and at the same time, it also experienced an increase in galactic cosmic rays and the strength of the interstellar magnetic field. Voyager 1 has continued to astound engineers when in December 2017, it successfully used its backup thrusters to orient itself so that it could communicate with it back here on Earth. Those thrusters hadn't been used since November 1980 during Voyager 1's flyby of Saturn. How's that for reliability? The Voyager probes are always sending out a signal. Each probe has a 22.4 watt radio transmitter, which is about equivalent to a tiny refrigerator light bulb. The mind-blowing thing is that by the time its signal reaches us, the power has been reduced to roughly 0.1 billion billionth of a watt. It's so small that NASA has to use its Deep Space Network array of giant radio antennas together, which consist of 3 facilities spaced apart from each other around the world: the Madrid Deep Space Communications Complex, the Canberra Deep Space Communication Complex in Australia, and the massive 70-meter antenna at the Goldstone Deep Space Communications Complex in Barstow, California. The sensitivity of NASA's deep space tracking antennas located around the world is truly incredible. These huge antennas must capture Voyager information from a signal so weak that the power striking the antenna is only 10 exponent to the -16 watts. A modern electronic digital watch operates at a power level of 20 billion times greater than this incredibly feeble level. And we're not done talking to the Voyagers just yet. On October 29, 2020, mission operators sent a series of commands to Voyager 2 after a long 7-month silence. The spacecraft had been flying solo while the 70-meter antenna at the Goldstone Deep Space Communications Complex was being repaired and upgraded. The amazing thing is that after all these years, and the fact that Voyager 2 is in interstellar space, it returned a signal confirming it had received the call and executed its new commands without any issues. As of January 2022, Voyager 1 is 23.3 billion kilometers from Earth, and Voyager 2 is 19.3 billion kilometers from us. Most of the instruments have been shut down on both of these probes in order to conserve power. Voyager 1 is headed in towards the constellation of Eucus, and in the year 40,272 AD, it'll come within 1.7 light-years of an obscure star in the constellation Ursa Minor called AC plus 793888. In about 40,000 years, Voyager 2 will come within about 1.7 light-years of a star called Ross 248, which lies in the constellation of Andromeda. But sadly, and much sooner than this, we'll lose contact with both of these spacecraft for good, and they'll pass silently into the interstellar void. It would be interesting if one day, in the very far and distant future, a civilization out somewhere out there finds a Voyager and learns to power it back up. If so, that primitive hardware might spin back into life one last time. Stay tuned here to see if the Voyagers find something new and to keep up with all the exciting things happening in our universe. Thanks for watching.